Hello and welcome to the Midas Ink Supply System webinar. My name is Alan Mutch and this is the second webinar in a series of 3. I hope that you find it useful and informative. This webinar is intended to be a practitioner's guide to the installation of the Xaar Midas Ink Supply System, how to install and integrate a system, how to operate the system including startup and shutdown, a tricks and traps practical overview including many frequently asked questions regarding installation, common faults and troubleshooting, and an overview of the spares and accessories proposition. If you have any questions, could you please save them to the end, but it doesn't preclude you from typing them during the course of the presentation so that I can answer them at the end. The new Midas system is a compact fluid supply system for original equipment manufacturers and integrators, looking for an off-the-shelf solution resulting in a fast time to market, therefore reducing development costs. The Midas system is robust, easy to integrate and is ideal for both prototyping and as a full production subsystem. We currently offer the Midas system in 2 product variations. It's fully compatible with the Xaar 501, 502, 1003, 2001 and 2001 Plus printheads. The Midas system is also compatible with most recirculating printheads on the market today. The photo on the left shows the Midas 450 system, which has a maximum flow rate of 450 millilitres per minute, which can be dependent upon inks and applications of course. It comes complete with one factory-fitted line connection set of solenoid pairings. The ink system volume is contained within a 60 millilitre tank, plus the volume dependent on the length of the tubing of course. The Midas 450 is ideal for applications with lower flow rates, particularly important for testing, development, or if the application has expensive fluids. The photo on the right shows the Midas 950 system, which has a maximum flow rate of 950 millilitres per minute. Again, dependent upon inks and applications. It comes complete with 2 factory-fitted line connection solenoid pairings. The ink volume is contained within a 50 millilitre tank, plus the volume dependent on the length of the tube. Please note that the fluid pump is separate from the main chassis of the Midas product body. The 950 is ideally placed for applications that have high volume and high throughput printing. The Midas 450 and the 950 is the same in basic layout except of course for the separate pump arrangement. The Midas range of ink delivery systems recirculate fluid using a pumped feed to the printhead with a vacuum return. This is different to some ink delivery systems available on the market today, where fluid is pumped in and then pumped out of the printhead or supplied by a differential weir. The flow rate of the fluid in the system will depend upon the pressure, head resistance and fluid viscosity. Therefore, the flow rate when the fluid is cold will be lower than when the fluid is warmed up. The Midas ink supply system controls the pressure of the fluid passing through the printhead, causing a meniscus of fluid to be formed over the nozzle. This can be thought of as a fluid passing a hole in a narrow pipe at speed. The precise pressure needs to be carefully controlled within the recirculation system, as any changes to viscosity, surface tension, temperature and pressure affect this balance. If the balance is incorrect, air can be sucked in or fluid can leak out through the printhead. The Midas 450 is supplied with one solenoid factory fitted. The Midas 950C or the core is supplied with position 1 factory fitted and has the option to populate the other 3 ports, providing a total of 4 ports in all. Additional solenoids can be populated as required by the end user. The Midas 950X or Extra is supplied with position 1 and 5 factory fitted and has the option to populate the other 3 ports, providing a total of 5 ports in all. Again, they can be added as required by the user at a later date. The chart depicts how many printheads can be supported by the Midas system. It's important to note that the number of printheads indicated has been put together and shown as a maximum flow rate. The Midas ink supply system has been designed for use with high-flow recirculating printheads and can be used with multiple printhead systems. Each printhead is able to be individually controlled and maintained via the Midas software. It is important to consider the weight and physical dimensions of the system when planning your integration to ensure that your system will operate flawlessly. It is also important to consider access to the Midas unit for servicing, modification and maintenance. Fluid tubing connectors between the Midas system and the printheads have an 8 mm outer diameter and a 6 mm inner diameter as standard. With fluid tubing connections to the filler pump inlet, they are 6 mm outer diameter and 4 mm inner diameter. Please allow for the RS422 and USB connection gateway adapter and connection cable inside the system. The maximum distance between the Midas system and the computer is 100 meters. Please also allow space for the power supply unit and cable, or alternatively make a provision to tap off from an existing power source within your design integration. The suggested distance between the Midas system and the printhead should be no more than 1 meter. The suggested distance from the bulk fluid tank to the Midas system is 2 meters. There is no limit if the remote fill pump is fitted. All Midas units have been assembled in a clean environment and every care has been taken to clean the units thoroughly before supply. We strongly recommend that the system is flushed before use. I will discuss this later in the webinar. It is important that you check fluid compatibility with components used within the Midas system as part of the pre-qualification of your purchase. When working with any kind of machinery, health and safety is critical. Safety goggles and nitrile gloves must be worn at all times while working on and with this type of equipment. Users must ensure that they are suitably decontaminated prior to eating and/or drinking. There is a complete health and safety list of hazards with the integrated use of this equipment in the system user manual, which I strongly encourage you to read prior to integration. I will now describe how the Midas system works. As you can see in the photo, I've positioned a printhead at the bottom to depict a system. In actual operation, the tubing would of course be extended to facilitate printing at the point of need. The image shows a labelled typical setup of a Midas system with a Xaar 1003 printhead. This setup is recommended for any through-flow printhead. Fluid is pumped from the bulk fluid storage unit using a chemically resistant diaphragm fill pump. The fill pump is remotely mounted near the bulk storage container. Fluid passes through an anti-siphon check valve into the Midas internal fluid reservoir. The check valve ensures that the fluid is held at the return pressure of the ink system. Without the check valve, if the external bulk fluid storage reservoir is closed to the ink system, then the valve set in the return pressure would cause air to be sucked into the system. The ultrasonic sensor within the internal fluid reservoir monitors the level of fluid. If the tank has not filled in 30 seconds, the pump will automatically shut off and raise an error. Fluid is pumped from the internal fluid reservoir along a depth filler or Degas matrix filter, using a damped multi-head diaphragm pump system to give a pulseless flow. The depth filter or Degas matrix removes any microbubbling formed by the pumping process. The suction pressure in the pump can take some fluid base solvents past their vapor point, making them outgas. It works by reducing the velocity of the fluid as it passes through. The bubbles, being larger than the filter membrane, roll to the top, where they are absorbed over time. When a Degas matrix is used, a 20 micrometer mesh filter will also be needed as a partial trap to potential particle traps within the system. Fluid flows through the sensor T-piece. This needs to be fitted as close to the printhead as possible after the depth filter or Degas matrix. In-feed pressure is measured here to compensate for any pressure drop through the filter and the pipework from the Midas system. Fluid enters the printhead at a positive pressure. The pressure can be dynamically adjusted from the in-feed pressure setting on the Midas system. The mounting height of the Midas can be compensated for within this. Fluid returns to the Midas system as negative pressure. We provide full details on how to achieve automatic calculation of recirculation meniscus settings within our user guides. The Midas unit must be mounted level and higher than the printhead. If it is mounted from the rear using 3 mounted screws. The mounting hole positions are detailed and indicated in the diagram. Failure to mount the system level may impact on overall performance. In systems where inertia is applied to the system should be mounted in the direction of travel, i.e. the mounting plate in the direction of travel, to reduce the inertial effects of the system and its contents. It is recommended that the units are mounted at least 200 mm, approximately 4 inches above the printhead. It is possible to mount the unit at a height less than this, but access to printhead connections and maintainability must be considered. The Midas systems are manufactured in accordance with EU Low Voltage Working Directive and are designed to operate from a single 24 volt DC 6 amp industrial grade switch mode power supply. All inputs are PNP and require a positive 24 volt DC signal to activate, and they are opto-isolated. All outputs are NPN and they are grounded, requiring a plus 24 volt DC supply to the device. If PNP outputs are required for low current applications, typically 20 milliamps, for PLC input, this can be achieved by fitting a 1K resistor between the plus 24 volts and the output, then taking the signal off the output, but note the signal will be inverted. For higher currents or for non-inverting outputs, the use of a suitable signal relay is recommended. There are a number of pipework recommendations. The length of pipe should be kept to a minimum with as few joints as possible. The length, bore and construction of pipework can have a profound effect on the fluid flow of the printheads, affecting print quality and performance. Keeping the pipework short also helps to reduce heat loss in the system. This can cause increased viscosity in the fluid lines, leading to nozzle dropout and poor print quality due to the reduced flow. On systems feeding 2 printheads from a single outlet, a T-piece is best used to split the flow, providing, of course, that it is of sufficient bore. On multiple printhead systems, the pipe length should be kept the same to ensure equal fluid flow. Printheads should be connected with flexible tubing. Tubing compatibility must be confirmed with your chosen fluid provider. Semi-rigid tubing, such as FEP or PTFE, may also be used. However, this can be difficult to work with, especially with bends. One trick is to put a wire down the middle to stop it collapsing, then heat it with a heat gun to bend it into shape, allowing it to cool and remove the wire. Softer materials such as Itron are more flexible while still affording good chemical compatibility. Jointing at the printheads also tends to be less reliable with semi-rigid tubes unless tube clips are used to ensure it grips the head barbs. The Midas unit pipework requires an additional sensor line to be installed on the in-feed side of the printhead after any filters or degas matrix units. Users should evaluate whether a degassing matrix would be beneficial within their system, considering fluid and pigment type and system setup. Degassing within recirculation systems can be desirable to counter the effects of any air that may have been absorbed by the fluid at the start or generated by the recirculation pump as the result of volatility of the solvent used in some fluids. Dissolved gas and microbubbles in certain fluids and system setups may also significantly affect the speed and quality of printing. By interrupting droplet formation or pressurization at the ink printhead, Dissolved gases can lead to improper jetting at the time of fluid ejection. This can lead to poor image quality and nozzle dropouts, which can cause expensive shutdown of the equipment and the need for more frequent cleaning. A possible solution to more severe problems is to use a degas membrane prior to the fluid reaching the printhead. Degassing fluid with a membrane is a simple process. The fluid flows on one side of the membrane while a vacuum is drawn on the other side. Gases dissolved in the fluid readily transfer through the membrane to the vacuum side, leaving the fluid degassed when it reaches the outlet. The degas matrix should be fitted in place of the depth filter, with a 20 micron meter last chance filter fitted after the matrix. Xaar can supply a suitable degassing unit as an optional extra if required. Fluid should also be filtered prior to use in the Midas unit. A 20 micron meter filter, or a filter size suitable for the fluid's pigment, should be fitted in the fluid line between the bulk tank and the fill pump. This ensured that any debris or sediment in the bulk fluid storage container is not transferred through the head. A last chance filter should be fitted near to the printhead on the infeed side between the outlet of the Midas unit and the printhead prior to the T-point to protect the head from micro bubbles and any debris that may have been created from reacted material or other debris from pipework. Although most printheads have their own internal filters, these generally are not user replaceable and once clogged can be problematic. If a degas matrix filter is fitted, the degas unit should be located before a 20 micron meter filter and the T-piece for the infeed sensor to ensure that filter protects the printhead should the degas matrix break up internally in addition to removing other debris. All replacement filters and fail-safe bottles can be purchased from Xaar. An optional degas vacuum source is available for use with a customer-supplied degas matrix. It is ideal for use on setups where machine vacuum is not available to drive a matrix, or within the machines where integrators prefer for the ink delivery components to be controlled separately from the main machine. The Degas vacuum source is capable of 720 millibar. It connects directly to the Midas unit, allowing it to be controlled and monitored by the main user software. The Degas source is connected using the supplied cable to the rear of the Midas unit via the plug shown in the image. The Midas units are fitted with a remote fill pump option. This is useful when the bulk reservoir is mounted a long distance from the ink system, allowing the fluid to be pressure fed to the Midas unit rather than relying purely on suction from a local fill pump. The remote inline heater is ideal for integrating into systems where higher fluid temperatures are required or longer pipe work is necessary. The heater can improve temperature control in many situations and generally reduces the stress on the fluid by allowing it to be heated more gently due to an increased surface area for thermal transfer. To install the software, click on the supplied .msi file. Follow the on-screen instructions illustrated. Leave the install directory as default. Click Next and wait while the software installs. And click Close to finish. An icon will be placed on the desktop and the Ink System Manager will also be displayed in the Start menu. Once the main user software has been installed, the USB driver must be installed and can be found in a location prescribed in the manual. To install the USB drivers, double-click ch341ser.executable file and follow the on-screen instructions to install. These versions of Windows have a feature in their security policies where the user settings will not store correctly when the program is run, i.e. COM port won't save. The The solution, and this only needs to be done once, before running the software, right-click on the icon or the software in the Start menu and click Properties. Then select the Compatibility tab. Under Privilege Level, select Run this program as an administrator. This will set up the correct security policy for the application folder. Press the icon installed on the desktop. This will show the main application screen. Once all pipework and electrical connections have been completed and checked, power may now be connected to the system. The unit will start up immediately. It may begin to fill with fluid if the ink enabled setting is selected to on. The meniscus pressures are set up using the user interface software. How the software behaves is dependent on whether Enable Circulation is selected. All the recirculation meniscus pressure settings can be automatically generated using the Support Calculation Wizard tool located in the user interface. Log into the software, click on the Advanced Setup tab or button. When prompted for a password, enter Calibration. Open the Setpoint Calculation Wizard, which can be found under the Extension Tools tab. Startup screen. An example is shown. You can then set the return height measuring between the points shown and insert the data. Alternatively, the plus or minus icon can be used, and click Next. In feed height, measure between the points shown and insert the data. Alternatively, the plus or minus icons can be used, and click Next. Use the Printheads datasheet to enter the recommended differential pressure and jetting meniscus pressure settings. These should ensure the desired flow rate is obtained. Default values of plus 60 and minus 40 have been set to generate a jetting meniscus of minus 10 millibars. This works well with most setups, so can be left unchanged if the printhead manufacturer's settings are unavailable. The pin out and pin in data will automatically be recalculated if the data in the box is changed. Once finished, click Next. Please note that this recalculation only works if the flow is referenced in the arrows. It also assumes that the meniscus pressure is negative, and then only the absolute value is used within the equation. Use the Printheads datasheet to enter the recommended differential pressure and jetting meniscus pressure settings. These should ensure the desired flow rate is obtained. Once again, default values of plus 60 and minus 40 have been set to generate a jetting meniscus of minus 10 millibars. This works well with most setups, so can be left unchanged if the printhead manufacturer's settings are unavailable. The pin in and pin out data will automatically be calculated if the data in the box is changed. Once finished, click Next. Please note that this calculation only works if the flow rate is as referenced in the arrows, as previously outlined. Enter the specific gravity of the fluid. Refer to the fluid manufacturer's datasheet for details. If unavailable, the specific gravity can be calculated by weighing a sample as per the instructions on the screen. A summary of the values entered and the final calculations are completed. Values can be manually changed by clicking in the relevant box and then clicking Recalculate. If these calculations are correct, press the Transfer Calculated Values to Ink System button, and all the relevant settings will be updated and reloaded into the main screen of the user interface. Open the Parameter Setup tab. Ensure the Enable Ink checkbox and Internal Enable checkbox are ticked. The internal enable box overrides the external enabled signal located on interface connection. Priming the system, the Midas unit must be powered up and the ink enable turned on. The fill pump will start. It has a timeout feature on it which automatically raises an alarm after 30 seconds of continuous filling and shuts down with the pump. The alarm may show if the unit is not yet filled. To reset it, press Reset Alarms. Note for systems using the recommended depth filter. Prime the filter by releasing the lure cap on the top of the filter whilst recirculation is running, holding onto the cap to ensure it is not blown off. Once fluid can be seen, retighten the cap. Flushing the Midas system before use. The Midas unit should be filled and flushed in situ with the integration pipework before first use. A flush product compatible with the desired end fluid and materials used within the Midas system should be used. A 5 micrometer filter should be used in place of the printhead during the flushing process to ensure there is no risk of damage to the printheads. Although every care is taken during the manufacturing process, this flushing ensures that any debris or residue contaminants from the manufacturing process or installation are removed prior to running the system with printheads and fluid. To fill the system with flush, follow the procedures for priming the system. Run the system for 20 minutes and now finally disconnect one of the lines attached to the filter and purge out the fluid. During normal operation, to ensure the fluid is given sufficient time to heat to the optimum temperature and mix, it is advisable to set preheat and bypass times using the user interface. These control the startup of the unit to raise the ink and then stir it ready for use. Log in to the software as an advanced user, click on the Parameter Setup tab and enter the required time. The startup cycle will automatically run sequentially at startup of the unit. However, it can also be restarted at any time using the button on the main screen, Continuous Bypass Mode. Continuous Bypass Mode is useful when fluid needs to continue to recirculate but not through the printhead. This can be particularly useful for fluids containing heavier pigments where settling is inadvisable. When in continuous bypass mode, the unit will recirculate fluid at the manual bypass speed specified in the External Setup tab. Log into the software as an advanced user, click on the External Setup tab, enter the required speed. To put the unit into continuous bypass mode, click Run Continuous Bypass from the main screen. The user does not need to be logged in to perform this task. Values can be updated by pressing the Update, Increment or Decrement buttons, and also if the Enter key is pressed in the text box in the relevant parameter. All the settings shown in the user interface are stored within the Midas unit. A local copy of all of the parameters is stored on exit of the software to a settings file on the PC. It is advisable to press Update from Unit when you first start up the system to upload the live data from the unit. This ensures there are no setting differences. This is especially critical when two systems are used at separate times from the same interface. Note, if you click the Advanced Settings button, assuming communications are running, the software will run an update from the unit automatically. Accessing the user interface. When the interface is opened, the functionality accessible to the user will vary depending on the user type. Passwords cannot be changed when a particular interface is open. Standard user, no password necessary, access to the main screen, ability to change displayed units unless disabled by an advanced user, and the ability to start a team viewer session. Within the Advanced Setup tab or button, passwords will be requested. For normal operations, the password is set to default as password. The following tabs are available to the user in the Advanced Setup mode: External Setup, Comms, Parameter Setup, Calibration and Firmware Upgrade. Locking the user interface, log on as an advanced user, click on the Parameters tab, and a technician can lock some features they may not want operators to be able to adjust, such as fluid, temperature, meniscus pressure, and purge time. To enable any of these features, click the relevant checkbox. Note, checking advanced password requires use of the password. Log in to the software as an advanced user, select the Comms tab, click on Port Name at the drop-down menu. Select the port name that represents the port your Midas is connected to. Please note the drop-down menu populates on application startup. If you have installed your COM port after you have started the application, your port will not be shown until you restart the software. Identification of the current user interface software version, which can be important if you're in dialogue with technical support or product support. Log into the software as an advanced user. The current interface version and release date is shown in the top box in the communication screen. Enabling the system, log into the software as an advanced user and select the Parameters Setup tab. Integrated temperature controller. The Midas units have two K-type thermocouple controllers built into them. The first is for internal fluid reservoir heating, and the second can be used as an additional channel for the optional external inline heater or external user thermocouple. Setting and enabling the tank heater, log into the software as an advanced user, open the Parameters Setup tab and enter the desired set point temperature in centigrade. The internal tank heater temperature by entering the required value into the text box and pressing update, or by using the increment decrement buttons, which will update automatically. These increase in increments of 1 degree centigrade. Once the desired set point is set, enable the heater by ticking the tank heater checkbox. The controller will now run in closed loop mode. Note the text box is input protected, so will only accept numerical values. The limitation within the box 0 to 65. Displaying the current tank temperature. The current tank temperature is shown on the main screen. It is always displayed whether or not the heater is enabled. Also note the thermocouple for the tank temperature is in the core of the heater. This means that the heater cuts off at the set temperature to protect the fluid. This is different to many other ink delivery systems on the market, where the heater stays on until the fluid has reached the desired temperature, as the heater sensor is positioned within the fluid. This may risk stressing or prematurely curing the fluid around the heater due to the fluid being heated above the desired temperature. Setting and enabling the external temperature controller. The auxiliary heater is only operational when recirculation is running to ensure it does not overheat static fluid. Log into the software as an advanced user, open the Parameter Setup tab and enter the desired set point in the same manner as previously described. Once the desired set point is set, enable the heater by ticking the AUX Heater On checkbox. The controller will now run in closed loop mode. Current alarms and status of the system are shown in the relevant checkbox list, and should an alarm occur due to pump timeout or something similar, these can easily be reset by clicking the Reset Alarm button. When an alarm is triggered, a red message box will appear on the screen detailing which alarm has been tripped. Click the Accept and Reset box to reset. The Midas units are capable of generating a pressure purge to the printhead, useful for both priming and maintaining the printheads. The units are capable of generating purge pressures of up to approximately 950 millibars. There are two types of purge available on the Midas range of products, soft and hard purges. A soft purge increases the pressure linearly from across the meniscus, thus the pressure increases the longer the purge is carried out. Automated hard purging is when the printhead lock-off valves are closed and the pressure inside the reservoir is allowed to rise to the purge pressure set point, then released. Any blockages in the printhead are more likely to be dislodged. Both types of purges can be triggered in three ways: via the user interface, via the hardware, i.e. the 15-way electrical connector, or locally using a push-button switch on the unit. It's important to note that it's advisable to not set a purge pressure higher than that recommended for your printhead. Purge pressures higher than the recommended pressure may cause permanent damage to the printhead. The Drain System Command checkbox. The Drain System Command, or checkbox, is used to allow the unit to be easily drained of fluid. The fill pump and the meniscus control are disabled, but purge operations still operate, allowing the user to purge all the fluid inside the unit out through the printhead. This can be useful prior to running flush through the system. Once purging is started in this mode, it will run indefinitely until the purge is cancelled by depressing the button or resending an electrical pulse. The purge will also be cancelled by unchecking the Drain System checkbox. Log into the software as an advanced user. Open the Parameter Setup tab and ensure the Drain System checkbox is ticked. Lab mode will disable the fill pump. This is useful when filling using a syringe instead of a fill pump, or if the fluid is used with a low specific gravity and the float switch has dropped. Log into the software as an advanced user. Go to the Parameters tab. Tick the Lab mode Fill Pump Disabled checkbox. Note the fill flag will still return the status of the level switch even when the fill pump is disabled. Startup cycle and bypass time. It is advisable to set up the preheat and bypass times during normal operation to ensure the fluid has had sufficient time to warm up and reliable operation of the system is facilitated. The startup cycle will automatically run sequentially at startup of the unit. However, it can also be restarted any time using the button on the main screen. Continuous bypass mode is useful for when fluid needs to be left to recirculate in the system but not through the printhead. For example, if the printhead has been removed and you do not want the ink system to settle. Manual speed control of the pump. The reflow pump has a manual recirculation speed setting. This is primarily used for the bypass flow on the pump, as this runs at a fixed motor speed as opposed to a pressure. However, this manual control can be switched on at any time as long as the recirculation mode is enabled, which is useful for setting up difficult low viscosity fluids and whilst flushing the system. Where direct support from Xaar personnel is required, a Team Viewer client is pre-installed inside the user interface. If requested, the client can be started as shown below. All users have access to this application, irrespective of the password setting. Click on About, select Start TeamViewer Session, click Yes or Accept for any security message. Give the ID and password to the person requiring remote access to the PC, and the support agent will now be able to access the control of the PC and hopefully resolve any issues that you may have been experiencing. If you have any security concerns, you may cancel the client at any time by clicking Cancel. There are a number of Midas accessories that can be purchased to either add to the system or be used as spares, including a valve set, spare fail-safe solenoid valves or spare de-airing solenoid valves, a remote heater, which again can also be used as purchased as a spare part, and degasser unit adapters also again can be fitted to augment an existing system or be used as a spare. There is also a remote manifold set. The photo shows the remote manifold set and heater assembled. This facilitates inline heating close to the target printhead. Of course, the power supply, which is a 24 volt DC switch mode power supply, and a comms link and cable can also be purchased. I've included a troubleshooting guide for you in a bid for you to be able to use these to solve any faults should they occur. We have an extensive suite of support material for the Midas product range, including data sheets, extensive user manuals and software manuals, Xaar Hydra versus Xaar Midas comparison charts, material compatibility charts and sample kits, and spares kits. On the 25th of May, we will embark upon our next webinar. There will be a sign-up link for this next webinar emailed as a follow-up after this one. The next webinar will be for advanced users and will centre around getting the most from your Midas system, software and some of the advanced features to optimise your system. If you have any questions or you do wish to contact me, please feel free to use the contact details on your screen now. Thank you. Bye-bye.